In this lesson, we're going to look at right triangle trigonometry, specifically the ratios that we use to determine missing sides and angles, and we'll get to finding missing sides and angles later on. But we're just going to define these trigonometric ratios. And basically, trigonometry is a branch of mathematics that uses triangles to help you solve problems. And whether you are a surveyor, a navigator, a machinist, an engineer, many of these occupations use trigonometry on a daily basis. The three main functions that we're going to look at are the sine, cosine, and tangent functions. Notice that I have these colored, and sine, even though it's spelled S-I-N-E, we abbreviate it S-I-N, and we still say sine. Cosine is abbreviated C-O-S, but we still say cosine, and tangent is abbreviated T-A-N, but we still say tangent. So when we set up to find a certain angle or a missing side, we're going to set up ratios. So these are the three main trig ratios that we're going to use: sine, cosine, and tangent. Sine is set up as the sine of this angle, and this is the angle we're referring to, equals the opposite leg over the hypotenuse. So the measure of this, the sine of this angle is equivalent to the ratio of these two sides. And then the cosine of this angle is equivalent to the ratio of these two sides, the adjacent leg and the hypotenuse. And the tangent of this angle is equivalent to the opposite leg over the adjacent leg. So a quick mnemonic device that is helpful for memorizing that is the word SOHCAHTOA. SOHCAHTOA stands for this: sine of my angle equals opposite of our hypotenuse. Cosine of my angle equals adjacent over hypotenuse. And tangent of my angle equals opposite over adjacent. So I have S-O-H right here, C-A-H right here, and T-O-A here. Now, the acute angle that we're talking about that's being used for the ratio is typically, you can call it the angle of interest, but it's marked with that theta. Remember, that's just a Greek letter that represents an... So that theta represents an unknown angle. And another unknown angle measure, or can be another letter, used can be phi. But it's more common that you're going to use theta. The three main ratios can also be shown as reciprocals. Remember, that's when I flip my fraction over. And we're going to talk about those. Those are our cofunctions, and we'll talk about those later on in this lesson. So it wants us to set up and find the sine, cosine, and tangent of angle A. Right now we're just setting up these trig ratios. We are not actually using them to solve for angles and sides, but we will be doing that very shortly. So we need to make sure we understand how to set up these ratios. So if I'm talking about angle A, then that means this is my angle of interest. So we could represent it with theta, we could use angle A, whatever we want to use. But basically, kind of imagine yourself standing right down there in that reference angle, and we're going to figure out our ratios. So in this case, we've got the sine of angle A equals the opposite leg over the hypotenuse. So the opposite leg across from A would be 9, and the hypotenuse would be 10.8. So I've got 9 over 10.8. If you can reduce this, go ahead and do that, but in this case, it's not going to look much prettier than that. We've got cosine of angle A. Cosine is adjacent, or the side right next to angle A, so that would be 6 over the hypotenuse, so 6 over 10.8. I could take each of these and really just give a decimal answer, but it's not really necessary. You certainly could. And let's see if it gives us anything nicer. Let's see, 9 over 10.8. Not really. So I'm going to leave this one. This one could be reduced. Both can be divided by by 2, but that's not really necessary either. Tangent would be opposite over adjacent, so I've got opposite would be 9, adjacent would be 6, so tangent of angle A would be 9 over 6. If I reduce that, that's going to be 3 over 2. Again, finding the sine, cosine, and tangent of angle A. Here's angle A, so there's my reference angle. You may want to go ahead and pause the video and try setting these up on your own. Since each of these include decimals, I am going to go ahead and divide them out and leave it as a rounded decimal. So again, if you want to pause it and try these on your own, now would be a good time. Alright, so I've got the sine of angle A. Sine of angle A is opposite over hypotenuse. So I've got 8.2 over 24.5. So that's going to give me approximately 0.33. Cosine of angle A is going to be adjacent over hypotenuse, so that's going to be 23.1 over 24.5, and that's going to give me approximately 0.94. Tangent of angle A would be opposite, over adjacent, so 8.2 over 23.1. And that gives me 0.35. Now again, these don't really mean a whole lot to us at this point, but when we begin using these ratios to solve for missing angles or solve for missing sides, we'll see where this comes into play. Right now we're just setting them up. Find each of the following trig ratios for the right triangle shown below. So now I'm going to set this up. Because these are whole numbers, I'm going to leave them as fractions so that I don't have to round. Again, you may want to try pausing it and setting these up yourself. This time we're going to do both angle A and angle B. So the first time you're going to be using angle A as a reference angle, so this would be opposite, this adjacent. And then next you're going to use angle B, and again now that switches. So this now is opposite and 5 now is adjacent. So sine of angle A, remember I'm talking about this angle here, opposite over hypotenuse would be, opposite over hypotenuse would be 5 over 13. Alright, and then we have cosine, or let's go over the tangent of angle B. So I'm talking about angle B, I'm standing over here at this angle, and tangent is opposite over adjacent, so that's going to be 12 over 15. Or excuse me, not 15, 12 over 5, sorry. Cosine of angle A, I'm standing at this angle now. Cosine is adjacent over hypotenuse, so it'd be 12 over 13. Tangent of angle A, tangent, I'm standing at angle A, tangent is opposite over adjacent, so 5 over 12. Cosine of angle B, cosine is adjacent over hypotenuse, so 5 over 13. Sine of angle B would be opposite over hypotenuse, 12 over 13. Using the figure as marked, name each missing angle. So here it gives me the ratio. Now I just have to fill in the correct angle. So sine opposite over hypotenuse would be 9 over 41. So what angle is 9 the opposite from? So here's 9. Opposite would be angle B. Tangent is opposite over adjacent. So opposite of 9 again is angle B. And cosine is adjacent over hypotenuse, and so adjacent to 9 would be angle A. Find sine, cosine, and tangent of angle B, so now we're talking about this angle here. So sine of B, cosine, and tangent. Sine of angle B is opposite over hypotenuse. So we've got opposite, which is 12 over 15. This can be reduced. 12 over 15, both can be divided by 3. Cosine of angle B would be adjacent over hypotenuse. So we've got 9 over 15. Again, can be reduced. That's 3/5. And tangent of angle B is opposite over adjacent. So 12 over 9 4/3. Sine, cosine, and tangent of angle A. Well, first of all, we need to find the missing side, because as soon as I go to do cosine, that's going to be adjacent over hypotenuse, and I don't have that missing side, or that side. So I need to set up using the Pythagorean theorem. Alright, so I've got 17 squared, which is 289, minus 64. I end up with 225. And then the square root of 225 is 15. So if you know your Pythagorean triples, that's an 8, 15, 17 triple. If not, don't worry about it. So I've got all three sides now of my triangle, and I'm going to do sine of angle A, cosine of angle A, and tangent of angle A. Sine is opposite over hypotenuse, so 8 over 17. Cosine adjacent over hypotenuse, 15 over 17. And tangent opposite over adjacent, I've got 8 over 15. Given the triangle, set up the three trig ratios, sine, cosine, and tangent for the given angle. Compare these to the trigonometric functions using your calculator. So I'm going to do, I've got all three sides. I'm going to use this angle right here. So I'm going to do sine of angle A equals opposite over hypotenuse, so 8 over 10. That reduces to 4/5. And then I have cosine of angle A is adjacent over hypotenuse, reduces to 3/5. And tangent of angle A is opposite over adjacent, and that's 4/3. So now what we're going to do is we're going to type this into our calculator. And if you look, first of all, you need to make sure that your calculator is in degree mode. So let me go ahead and start up my calculator. So first of all, you need to make sure your calculator is in degree mode. So if you hit mode, you need to make sure this is highlighted, degree. If it's not, you need to arrow down until you are over it, and then go over to degree and hit enter, and that'll make sure it's in degree mode. Alright, so now I'm going to type in, let's see what we're looking at, the sine of angle A, which is 53.1. So I'm going to type in sine of 53.1, and that's going to give me an answer of 0.79968, which is very close to 0.8, but it's right there. And if I do 4/5 and compare that, I get 0.8, so very, very close. Again, if we rounded, it would work. Cosine of angle A, I'm going to do cosine of 53.1. And I get basically 0.6. And then if I do 3/5, again, I'm getting 0.6. And it would be the same thing with tangent. If I do tangent of angle A, which is 53.1, I get 1.33, and if I do 4/3, I also get 1.33. So just to show that it does work, or that these two, are equivalent, that the sine of this angle, 53.1, is equivalent to the ratio of the sides. All right, lastly, let's talk about cofunctions. Each function, sine, cosine, and tangent, has a cofunction. And cosecant is the cofunction of sine. Secant is the cofunction of cosine. And cotangent is the function of tangent. Okay? To find the cofunction, all we do is take the reciprocal of the original function. So sine is opposite over hypotenuse, which means that our cosecant, which we abbreviate like this, instead of opposite over hypotenuse, it's going to be hypotenuse over opposite. Okay? What I normally do is I just find the sine and just flip it over. Secant, I've got the abbreviation looks like this. If cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And tangent's cofunction is cotangent, and this is our abbreviation. And tangent is normally opposite over adjacent, so cotangent would be adjacent over opposite. So again, if you just find sine, cosine, tangent using SOHCAHTOA, then to find their cofunction, all you have to do is to look at the reciprocals. So let's look at secant, cosecant, and cotangent for angle A. So here's angle A right here. If I'm looking at cosecant, secant, and cotangent, okay? Again, I don't like to have to memorize more than I need to, so I just look at the cofunction and then flip it over. So cosecant goes with sine, so sine of A would be opposite over hypotenuse, 9 over 15, so I'm going to flip that over, or use the reciprocal. Reducing, I get 5 over 3. Secant is the cofunction of cosine. Cosine would be 12 over 15, adjacent over hypotenuse. So I'm going to flip that over, 15 over 12. Reduce that, and I get 5/4. Lastly, cotangent. Cotangent is a reciprocal of tangent. Tangent would be opposite over adjacent, so 9 over 12. So I'm going to flip that over to find the cofunction. Reduce that, and I get 4/3. So now we know how to set up trig ratios, and in the next couple of lessons we're going to look at how do I find the missing side or missing angle using these trig ratios that I've been able to set up.